Hello, my name is Elijah Davis, and today we're going to take a quick look at building a connector SDK with the assistance of AI. Specifically, we're going to use Visual Studio Code and GitHub Copilot. Now, to get started, we will be in the Fivetran documentation under Connector SDK examples, where we'll find a link that has tips for working with AI. Following this link, I'll see an agents.md file that has system instructions that you can use for any AI model or Copilot initiative to help you rapidly build Fivetran Connector SDKs. So inside of this, we'll have the core identity and purpose, response frameworks, technical requirements, how we want it to test and validate, file generation rules, configuration.json, etc. Everything to drive your solution to success in a programmatic and agentic fashion. So we take this information and we jump over to VS Code. And if we do add context, we can add instructions and create a new instruction file. I've done this and I've named it Fivetran Connector SDK, at which point I can now reference it in my prompt. So now we have everything set up from an AI assistant standpoint. We now need to build our project directory and define the data source. So inside of our IDE in VS Code, we've created a new folder called FDA Tobacco. Inside of this, we have three empty files: configuration.json, connector.py, requirements.txt. We also added a fourth one, readme.md. We're going to ask the AI to create our solution inside of these files in this project folder so that we can get a tight-knit solution. You'll also notice two other files, notes and fields.yaml. This is information taken directly from the source documentation. As described, it is FDA Tobacco, so we're going to jump over to that API definition, which we have here. So on the FDA website, we have the authentication information. We also have endpoint information for how to use the API, example queries with responses, all of the information we would need to build a solution. So we took some of this information from these URLs and added them into our notes.txt. Reason being, we're going to add that as context to our prompt in order to get a working solution. So we grabbed information from authentication, the how-to, this is all in here, and then same with the example queries and responses. This is going to give us, ideally, a highly performant solution, given that we've provided enough context for the data source. All of this lies in our project folder, at which point we build a prompt. So this prompt can be broken into three sections. The first section is our source context. Here's the API, here's the endpoint, here are some pertinent notes that I as a developer or I as a user have found that I have needed to know to interact with this data source. So I'm going to throw those in notes.txt. And then anything that was available even more, like fields on what returned from the API, I'm going to add that as a YAML file. This is directly from the website here, just downloading the YAML, which is just going to give better context. So I add that in. Our second section of the prompt is more of a bit more specific on what we want it to do. So we want it to dynamically create tables. We want it to flatten dictionaries. We only want it to do it for the first 10 responses because we don't want to burn through our limits. This is a free API. And then the third section is where we are specifically saying, do this with the best practices in mind that are in the instructions file that I have saved. And when you are doing this, create it in the project folder that I've created. So FDA Tobacco with our empty files. So at this point, we're in a good place to submit our prompt. On the bottom, we're doing an agentic approach. We can pick the model if we so choose, and we can submit our request. Perfect. As it's done its analysis, it is now working on creating the solution. There we go. It just created the connector.py. So we're seeing that in real time. It is now creating the requirements, config, and readme. Beautiful. So now we have our solution. We're next going to ask it to test it, but first we're going to approve of these changes. So we have all of our information. We have our notes, our fields, configuration.json, connector.py, etc. So now that's great. Let's have it test. Test the solution using Fivetran debug to make sure it works. Great, so it generated the command. I'm going to ask it to run it. Ooh, it encountered an error. It needs to be in the right directory. So it's going to do that first. Now it's going to change directory and generate a new command. As we can see in the bottom, the connector was successful and it did 10 upserts. So this is looking great. Well, now we need to review this. Show the top 10 records using DuckDB. Let's take a look at this data. All right, it's generated our command. There it is. We have product failed, reported health, the 2075264. So now that once we review the data, we can see these top 10 rows. And at this point, we're feeling confident we can deploy the connector. So I have a command here that we can use. And I'm just going to say, great. Deploy the connector using And at this point, our connector has been created with the following connection ID in this destination under this name. So let's actually go take a look. And we can see our connector SDK, and we can sync the data. So in this example, we took a contextually driven prompt that we seeded with information from a system instruction file made available in the Fivetran Git repo. We also created a custom notes.txt full of pertinent information that we deemed relevant for our connector SDK build. We also added documentation that was available online to give it more context on the fields that were available. We then asked it to create this connector and successfully tested it in the chat by asking the agent to run these commands. Not only that, when it encountered errors with what it was doing, it was self-resolving to the best of its ability, to the point where we were able to query the data and deploy our connector into Fivetran and sync data. All in all, this has been an AI demonstration. This process could be done in any IDE or AI model. For this demonstration, again, I used VS Code, GitHub Copilot, and GPT 4.1.